So what they're asking us to do is find the probability, uh, if two cards are selected at random, that they are basically both either clubs or threes. All right, so the probability that the first card is a club or three times the probability that the second card is a club or three. Because it's two cards being selected, so multiple cards means multiplication. All right, because you really can't have more than one thing without incorporating the word "and" in there somewhere, and multiplication is the rule of "and." All right, so it would have to be the first card is a club or three, and the second card is a club or three, even though it wasn't directly stated. Okay, probability of getting a club or three in general would be 8 out of 14. Probability of getting a second one, 7 out of 13. All right, so again, you could use the permutation notation, or you could just do, in this case, just two values. So, I mean, it would just be fancy for the sake of fancy. So 56 over 182. All right, number 11, what is the number of possible winning numbers in a lottery that consists of 6 randomly chosen values from the set of 1 to 54? All right, so that bracket notation, again, just means that we're including the 1 and the 54 as possible outcomes. All right, so we'll just focus on that before we get to the what if part. What is the number of possible winning numbers in the lottery that consists of 6 randomly chosen numbers from the set of 1 to 54? All right, so here we have a total of 54 values to play with. And from those 54, we need to choose 6 of them. All right. Traditionally, in a lottery, the order would not matter. So 54, the order would not matter traditionally in a lottery. So we use the combination for that. All right. Order does not matter. If I choose, I'll just dial it down because I don't want to name 6 numbers, but if I were to name like 3 numbers in the lottery, 1, 7, and 13, if they came up in the order of 13, 7, and 1, I still win the lottery, right? So I didn't have to get them in the right order. So that's licensed to use a combination, and again, because order does not matter. So what we do is we pop this in our calculator, see what we get. If it's anything too funky, we just leave it like this. Math, probability, option 3. Type in the 6. That's reasonable enough so I can write it. 258-27165. Oops. I already figured out. 27165. All right, and again, this is because order does not matter. Now, the follow-up to that would be that you do have to get them in the correct order. That takes our combination and makes it a permutation. So I'll take a look at that number in the calculator. Permutations, equivalent permutations are always much larger than their corresponding combinations. And I see here we have that scientific notation, the E10. And what I mentioned in class was that generally, if this comes up, we leave it as the permutation. If we leave it in permutation notation, we don't write the decimal. Because this is telling me to move the decimal point over 10 spots. 1, 2, 3, 4, 5, 6, 7, 8. And then I would just throw in 2 zeros. But those would be extremely rounded values, and they're not going to be anywhere near accurate. If we're going to get numbers that are all over the place that are nowhere near what the correct value is. So this is an estimator that's not really that good of an estimator. The better form is to just leave it as a permutation. Right, so, I mean, the only thing, I guess, I mean, if you, on the test, you forget this, just, you see that right out the whole thing with the E, but even still, it's just not good. I mean, this is not a good answer. This is a good answer. Question? Math, hit the left arrow once to get to probability, and then you have everything you need.
So we leave the pre-numbering and the ugly number we leave this before.
Yeah, exactly. Whatever it's asking, yeah. Yeah, in this case it asks for both. The first part said, what is the number of possible winning numbers in the lottery that consists of 6 randomly chosen values from set of 1 to 54? So it's just traditional lottery. Order in which I selected doesn't matter. What if, in addition to getting all the numbers correct, you also had to guess them in the correct order? Order matters. Permutation. All right. Number 12. How many events are in the sample space for 9 rolls of a fair die, followed by 3 flips of a fair coin? All right, so let's see. 9 rolls of a fair die. So that would be, well, there's 6 outcomes in a single roll. 9 rolls. Three flips of a fair coin. A fair coin, 2 outcomes per flip. And then we have 3 flips. Followed by, it's implying an and situation. And means multiply. All right, so 6 to the 9th times 2 to the 3rd. Same idea as that permutation stuff. Some of these numbers can get really astronomical. So pop it in. If it gets too funky, then we just leave it as is. But you do have to check, because if you can report a clean-ish answer, then you need to report that clean-ish answer. And just bear in mind what you define as clean and what I define as clean are not always the same thing. This is the clean number. It doesn't have that scientific notation in it. So 806, 21568. You would just leave, if it had that scientific notation, I would just leave it as 6 to the 9th times 2 to the 3rd. 2 to the 3rd. Yeah, I wouldn't do it.
How many more tests do you have? Just one?
Oh, you missed the whole spiel. For some people, none. For some people, 2. Because if you opt to do the paper for the 3rd unit, you would not have to take the 3rd unit test. if you are happy with your average after you have 3 test scores in, then you don't have to take the final. So today could be the last unit test that you take. However, if you opt to take the 3rd test and you are not happy with your final average after the 3rd test, then you would take the final so you could have 2 more exams. Or you can go, kind of a mixture of the 2 ideas. You take the 3rd unit test and you're still happy with your average after 3 tests, in which case you don't take the final. So anywhere in the set of 0 to 2 would be my answer. I will.
If you remember the first problem again, so I missed that one.
I can go. I can talk to you about it. Yeah.
Well, no, I meant just like scroll up so I can see what the answer.
I was gonna go to Ken first.
Oh, okay.
Yeah,
Oh,
but yeah, I can definitely show you. I really care about the answer more than anything, but anything that supports that is going to be a good thing. Yeah, that's why I'm going to go. Honestly, I wouldn't go over it except after I put it on the review. I was like, oh, this one's kind of juicy. So let me go over it.
On your list of what's going to be a potential set, the addition rule question, would that be number 10, the cards?
Yeah, because that was the either or case. Yeah, but it involved both. Generally, you can't get one without the other in order for a problem to make sense. So. All right, so for the Ken, again, you're dealing with the numbers that relate to the dimensions. So in this case, the numbers 1, 2, 3, 4, and 5. All right, so those are the only numbers you can work with. I'm making it a point to go over it because I saw some negative numbers in the last Ken, some fractions, some zeros. I'll take the heat for that one. Yeah. So this one is a pretty tricky one because of these areas here. What it's telling us is that we need 3 values that divide to equal 1. Okay. So however that works out, that's the important piece. But you also have to bear in mind that sometimes eliminating numbers from possibilities are also going to be a useful thing to do. So for example, in the 24 multiplication area, so I need 4 values that multiply to equal 24 from the set of 1, 2, 3, 4, and 5. Which number would not make sense? 5, right? Okay, so I now know that in this red area below, the 5's got to be in there somewhere. It's just a question of where. So maybe that's something you make a little note about, or maybe you just kind of file that information away. But you can kind of have the makings anyway of a little mini conclusion. All right, so I'm just going to say the 5 is going to be in there somewhere. But you also, I mean, it's always a good strategy to try to find things that you think are obvious. Like, for example, 2 numbers that are going to multiply to 20 are going to be what and what? 4 and 5. The only issue that I'm ever going to run into here is order. I don't know which one's the 4 and which one's the 5. So I'll make a little note. One's the 4 and one is the 5. So then I look at what's left over in that last column, 1, 2, and 3. So I make little notes. Okay, so 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. Until it starts kind of solving itself. Because eventually that happens, it's just a question of when. All right, so things like that, they're really important. But things like tendencies, things that keep coming up over and over again, that you want to take note of these things because, for example, the 2 with division, it always involves a 2 in a 5 by 5 puzzle. So if you're dealing with, you just kind of jot it off on the side, 2 with division has to be 1 and 2 or 2 and 4 in some order. So I know that the commonality there is that there's going to be a 2. It's just a question of, again, which one's the 2. But I know that there's going to be a 2 in there. So that kind of steers me in the right direction. All right. But like you may go back to that red area there and say, okay, well, how can I divide to equal a 1 if I have a 5? What else would I have to have? I'd have to have another 5 and a 1. All right. The only way that this could play out would be if the 5s were here and the 1 is there, because I can't have the 5s in the same row or column with each other. All right. So that's a little conclusion that you can draw. I also can use that 1 in the lower left-hand corner to help me at least narrow it down over here. I know that this has to be 2 or 3 now. It's a little bit, but it's a step in the right direction. Over here, I know that these have to be 2, 3, or 4. All right, and don't forget, at the heart of this whole thing, it is really a math puzzle. Don't forget that the math part of it can be a guide also. So I know that I have 4 values that have to multiply to 24. I have 3 of those 4 values. 4 times 3 is 12, times 2 is 24. So that's telling me that this last entry here has to be a 1, because I've already gotten to the 24. So I don't need to go any higher. So I now know that that's a 1, which is great news, because when it comes back to the 2 division, I had a choice between this and this. Well, it's not the one with the 1 anymore. It has to be the one with the 2 and the 4. So little notes. All right, if those are 2 and 4 in some order, then the one on top has to be a 3. So I have a conclusion, a little conclusion, a mini conclusion. Helps me narrow the field a little bit. So, and that's the thing that can be really frustrating about it. Like you make a nice conclusion where you're like, oh, I figured something out, and then it only helps you fill in like 1 cell, and you're like, wow, that sucked. But that's just how it is. Now, number sense will play a role here. If I'm looking at, let me get purple, this cage here, 2 with division, and then just look at your domain. 1, I'll just write them here, 1, 2, 3, 4, and 5. In that bottom row, the 1 and the 5 are gone. I've already used them. I need 2 numbers from whatever remains that are going to subtract equal 2. What are they going to be? 2 and 4, right? So that means that this guy over here has to be a 3. So then just like the lower left-hand corner with the 5s, if I'm going to divide to equal 1, I know I have to have another 3 in there somewhere. And that's telling me that this has to be a 1. Okay, so now some conclusions are happening. 2 up top, yeah. Then upper left-hand corner is now going to be a 4. Because it was a choice between 2 and 4. All right, so then, go where your instincts take you. Mine are telling me to go top row. I use 2, 3, and 4. That leaves 1 and 5 left over. All right, so you could start playing the what if game. You don't want to do this all the time, but sometimes it can get the job done. So I would say, all right, well, what if this number was a 5? 5 plus 3 is 8. I need to get to a 9. What would this have to be? A 1, but I already have a 1. So then this can't be a 5. I have a contradiction. All right, so it must be the 1 here with the 5 there. And that allows me to determine that this has to be a 5. Now, I need to get to a 1 through subtraction. I have a 5 and a 2. If I'm subtracting those, that gets me to a 3. I need to go 2 more to get down to a 1, right? So then 3, 2 by process of elimination. 4, 2, also process of elimination. I'm just cleaning it up now. Because those little mini conclusions along the way help us make the mega conclusions down the line. So 5 and 4. We have a 4 here. In the purple cage below, it was a 4 or 2. So now I know this has to be 2, 4, 1, and then that would be the 3. And then it would say congratulations on the screen and like balloons and fanfare and everything. It's just wonderful. Yeah, it's an acquired taste. It takes a lot of getting used to. I was not good at it initially. So why do you make us do it?
Start the review with the can.
Okay,